Now, when we do one of these problems in the future, I'm just going to write up the solution because I think people need to read a lot more than we're going to do this. But I did want to make one video to see if I couldn't convince more people to do this problem, not using arc length formula, but just using conversion fractions. For example, we have a circle here of radius 23.7 feet. We have some arc length along this of 100 feet, however long that is. And I just want to convert the 100 feet into degrees. So what I'm going to do is I'm going to write down 100 feet. I want to multiply by a fraction where degrees are on the top and feet are on the bottom. That way when I multiply it out, I'm going to have degrees left and not feet. Now, how do I find the numbers here? I usually just do one lap. One whole lap is 360 degrees, and that's equal to one whole lap of circumference. One whole lap of circumference is 2 pi times 23.7 like this. The feet cancel, and according to my calculator, we get something like 241 point, and I don't like to round if I can help it, 754,3439 degrees. Now, a couple things. Remember that halfway is about 180, 3/4 is about 270, so we're sitting about here right now. Now the next thing I want to do is do the radians. I'm still going to start with 100 feet. I don't want to start with an estimate and make the estimate worse. So I'm going to start out at 100 feet. And what I want to do in this time is multiply by a fraction. The feet have to go down here like this. Radians need to go up on top like this. That way the feet will cancel. And a lot of times I'll just write rads. So I'm going to write rads like this. I guess I'll write as much radians as I can. Now, how do I do this? All the way around the circle is 2 pi radians, remember, because that's measured as distance around the unit circle. The feet is going to be feet of circumference, which is the same thing it was before. I'm going to get 23.7 right here. Now, before we do the canceling, I'd like to do the following. Yes, I know that all the way around the circle is about 6.3. To get here is about 4.7. I'm thinking this is going to be something like 4.4-ish. I'm not sure. We'll see. Meanwhile, I go cancel, 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 cancel. We just get 100 over 23.7. And my calculator says something like 4.219. So my estimate was off a little bit. But I don't care. It was quick. It was decent. And that's what I want out of it. That's as hard as it is to change arc length to radians or arc length to degrees. You just multiply by the right fraction that puts the right units in the right places, and you get answers that you can check with the unit circle. Try that instead of using the arc length formula.